Multithreading in Java. Multithreading helps us to improve the performance of our application by utilizing the CPU time effectively. We will split our application into different parts and executing those parts of the application simultaneously by utilizing the CPU effectively. This is about today's agenda: multithreading concepts, creating threads, thread states, controlling threads, and summary about today's session. Multitasking is nothing but handling multiple tasks at the same time. How operating system will handle multiple tasks? Nowadays, CPU comes with multiple cores. Each and every core of the CPU will create separate process to execute separate tasks. In this slide, there are 4 tasks: word processor, email, web browser, and antivirus. To execute all these 4 tasks, operating system will provide separate process for all these tasks. So that's how operating system will execute multiple tasks at the same time. Now, multithreading. How multithreading will be handled by operating system? Operating system provides multiple processes. Under a process, multiple threads will be created, and all the threads will execute independently. If any exception occurs in one thread, which will not affect to the other thread. So in this slide, in process 1, 3 threads T1, T2 and T3 will be executing, and in process 2, 2 threads T1 and T2, and in process 3, thread T1 will be executing. Now, how multithreading helps us to improve the performance of our application? See, in this slide there are 3 threads: thread 1, thread 2 and thread 3. If thread 1 is waiting for IO resource, CPU will be idle. We are utilizing that idle time to executing another thread, that is thread 2. Similarly, thread 3. That's how we can utilize the CPU time effectively. Now, how multitasking differs from multithreading? Multitasking threads require less overhead than multitasking process. Process or heavyweight tasks which require their own address space. Context switching from one process to another process is costly. Threads, on the other hand, are lightweight. They share common address space. Creating thread. Threads can be created in Java in 2 ways: by extending thread class or by implementing runnable interface. Now, point is when to use either a thread class or a runnable interface. If a class become a thread, it has to extend a thread class. Then we cannot extend another class because there is no concept of multiple inheritance. If a class want to extend a class and at the same time to become a thread, then we have to implement runnable interface, which allows subclassing other class. Now, life cycle of threads. If we create a thread which is in a newborn state, to execute that thread we have to run start method on the thread. If we run a start method on the thread, it will go to ready to run state, I mean runnable state. It is not running state, but it is ready to run. It needs CPU time to be given. A scheduler has to schedule the thread. Once scheduler schedules the thread by calling a run method, it will go to running state. While running the thread, it may goes to block state by calling sleep method, wait method, or by blocking for IO, or by calling suspend method it goes to block state. Once it completes its sleep or lock is available, IO completes, or by calling resume notify all, it will go to again ready to run state. Again it will require CPU time, or scheduler has to schedule the thread. Once scheduler schedule the thread, once again it will go to running state to execute the rest of the statements. Once all the statements executed in the run method, it will go to death state. Even it will go to death state by calling stop method. These are the life cycle methods of the thread. These methods are from thread class, which is java.lang package, which is a default package. Even runnable also is from java.lang package. Thank you.